right, let's start making our way through this. Even if you're not all the way done with it yet, that's okay. All right, so the first thing they wanted us to do was use quadratic formula. So I have x equals be negative 16 plus or minus. What's going to end up under my radical when I simplify that? 48 all over negative 4, because it's 2 times a, right? Can I simplify the square root of 48 at all? What's that going to be? 4 square root of 3. So I have negative 16 plus or minus 4 square root of 3 all over negative 4, and then I can reduce that because everything that's outside the radical can all be divided by what? Negative 4. I would divide it by the negative since that denominator is a negative. So I would get x equals 4, because that's going to change it to a positive. Oh, thank you. Do I have to worry about the sign for the second piece? Like when I reduce the 4 square root of 3 by negative 4? No, because I already have both signs there. I have plus and minus. So it's not going to change to be minus plus. That just means the exact same thing. So 4 plus or minus the square root of 3. So here's my zeros, my roots. For my sketch, I'm probably going to pop those in my calculator so I have some idea of about where they are. Which means on the test, unless it comes out to like nice numbers, I couldn't ask you to do that, right? How am I going to find my maximum or my minimum? What will allow me to find the maximum or the minimum? Close. I'm going to know whether it's a maximum or a minimum based on the a value. Based on this, are we going to be looking at a max or a min? Max. How do you know? Yep, a is negative, so my parabola is going to look like this, right? So right up here is where I would find that maximum. What part of the parabola do we call that? Vertex. I want to be able to find my vertex. How can I find the vertex? Complete the square. So to complete the square, if you guys remember from last week, I usually kick out that function notation, and we're going to move our c value to the other side. So I'm going to end up with positive 26 equals negative 2x squared plus 16x. Do we have an a value other than 1? Yes. Then I need to kick that out to the front. If your a is anything other than 1, you got to take it out of these two pieces and kick it out to the front. So I'm going to have 26 plus whatever I kick out to the front. Remember, I have to multiply over here. Negative 2. And that would give me x squared, and then I would have minus 8x plus something. How do I decide what goes in there? Negative 8 divided by 2, and then we square it. So I have negative 4 squared, which is 16, both spots. So over here, I have 26 minus 32. What is 26 minus 32? Negative 6, right? Yes? No? Correct me if I'm wrong. Wouldn't be the first time. So I'm going to have negative 6 equals negative 2, and then what does this look like? X minus 4 squared. So putting it back in function notation, I'm going to kick that 6 back to the other side. That's my k value. So I would have negative 2 times x minus 4 squared plus 6. So I would say that my maximum happens when x is 4. What is the maximum value? 6. This part over here is my maximum value. And then this is the x where that occurs. That's really messy. There we go. X where the max occurs.
Where did you get the 4 from?
From the h value, from right here. Remember, what I see there is always the opposite. It would mean to go to the right 4. I still need a sketch of this. So I'm going to draw an x-axis and a y-axis. 4, 6 is my vertex. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. There's my vertex. Can somebody grab a calculator? Cell phone calculator is fine. We want to figure out approximate locations of these roots, just so I know about where to put this for my sketch. I need 4 plus the square root of 3. So if you're using a cell phone calculator, you do square root of 3 first, and then plus 4. Square root of 3 plus 4. 5.73. So that's going to be right here-ish. So something like this. And then I need the other one. So I have to do square root of 3 on the calculator first. And then we have to make it negative, because we're supposed to subtract that from 4, right? So square root of 3, make it a negative. You should have a plus minus symbol on there. Yeah. And then do plus 4 again. 2.27. So 1, 2, so right about here-ish. You guys okay with our sketch? Okay. Again, if I want a really precise sketch from you on the test, I would have to give you something that's easier for you to find on those roots. Yes, sir.
I don't get why on the roots for the 4 right next to the square root of 3.
Yep.
Why doesn't that simplify to negative 1?
So we already have both symbols. We have a plus and a minus right here.
Oh.
So if I do 4 divided by negative 4, I get negative 1 square root of 3. But if I do negative 4 divided by negative 4,
Gotcha.
I get a positive 1 square root of 3. So I just keep both symbols right here. Does that make sense? Okay. All right. Let's look at writing some equations. We've done something similar to this before. We were writing standard equations for any parabolas. Do you guys remember what standard form for a parabola looks like? What form is that? Close. This is our vertex form. Standard form is vertex form. So this is our AHK form. General form is the one with ax squared plus bx plus c. Whenever they say standard form, for the purposes of like what we're doing here in pre-calculus, standard form for a parabola is our vertex form, our transformation form. So I'm going to start with that idea in mind. And they've given me the vertex. So what pieces of information do I have to work with?
H and K.
I have H and K. So we can go ahead and substitute those values in. So I'm going to have y equals a times x minus what? 0 squared plus k minus 2. Yep. My final answer for this is going to look a whole lot like this, except I need to simplify it and I need to find a. Can I simplify this at all?
Yes, you can get rid of the minus 0.
I can get rid of the minus 0. And so this would just become y equals a x squared minus 2. Final answer for this will look exactly like this, except we're going to replace that a value. This is where that other point comes in. When it said find the equation for any parabola with this vertex, that's how we left it. But now I don't want the equation for any parabola. I want to make sure that this parabola goes through the point 325. What pieces of information are they telling me when they give me an ordered pair?
X and Y.
They're giving me an x and a y. So I can take that x and y and I can substitute it into what I've got so far and use that to find my a value. So I'm going to put 25 in the place of y. I'm going to put 3 in the place of x. And then I'm going to solve this. Order of operations says to start where? I can add 2 to both sides. We can do both of them at the same time. So that would give me 27 equals what? 9a. So what is my a value? 3. Divide both sides by 9. My a value is 3. So what is my equation for this parabola?
Y equals 3x squared minus 2.
Y equals 3x squared minus 2. Beautiful. So far, so good? All right, let's do another one like this one. Put that down, please, sir. I've got my vertex. So we're going to substitute into standard form or into vertex form. So what does it look like when I just substitute in that vertex?
Y equals a parentheses x minus 3 squared plus 1.
Yes. So I've got my h and my k right here. They told me that the x-intercept is 0. That's the same thing as telling me an ordered pair, right? What would that ordered pair be? 0, 0. So this is what I'm going to put in for x and for y to figure out a. So I would have 0 equals a times 0 minus 3 squared plus 1. 0 minus 3 is what? Negative 3. I'm going to go ahead and, not add 1. I'm going to subtract 1 from both sides. So I would have negative 1 equals a, and then I have negative 3 squared here. Negative 3 squared? 9. So I have negative 1 equals 9a. Which means a is 1/9. Or sorry, negative 1/9. My apologies. So what is my equation then?
Y equals negative 1/9 times x minus 3 squared plus 1. You guys feel okay about finding the equation of a specific parabola? All right, we have two more types of problems to look at here. First one is this guy. I want to find the maximum vertical distance, which is being described as D, between the parabola and the line for this green region. So right here is what I'm trying to find. And I have this equation for the parabola, right here. And I have this equation right here for this line. Whenever you see words like maximum or minimum and we're talking about parabolas, what does that make you think of? Vertex. Here's how we're going to find that maximum distance. My distance is equal to, I'm going to do the parabola. That's my shape on top. Minus my line, because that's my shape on the bottom. And I have equations for both of those, right? Do I have equations for the parabola and the line? Yes. So we're going to substitute in those equations. What's the equation that I have for the parabola? And then I'm going to subtract the equation that I have for the line. What's the equation for the line? Who can tell me what I just did wrong? Gotta put that inside parentheses. Anytime we're subtracting more than just a single value, you've got to remember we're subtracting the whole thing, so put it inside parentheses. So I'm going to distribute. So that's going to give me negative x plus 2. I want to combine my like terms together. So what would I get when I combine those like terms together? Negative 2x squared plus 3x plus 5. I want to find the maximum vertical distance, which means I want to find the vertex, and I want the y part of the vertex. So max distance is the y part of the vertex. There are two ways that we can go about doing this. So we have to make a choice. They'll both result in the same final answer. What's one way that I could take this and find the vertex? I can complete the square. We've practiced that quite a few times already, right? There's another way that I can go about answering this question. And we haven't practiced that, so I want to do that this time. The other thing that I can do is I can use part of the quadratic formula. The x part of the vertex is negative b over 2a. Does that look like a piece of the quadratic formula? What part's it missing when we talk about quadratic formula?
Plus or minus.
Yeah, plus or minus the square root of our discriminant. So it's the negative b part and then it's the denominator part. That will give me the x part of the vertex.
And since I'm in general form right here, if I can find the x part of the vertex, all I have to do is substitute that in, and I can get that maximum distance, the output. So this is the one that I want to practice right now. So what's my b value? 3. So I'm going to do negative 3 over 2a. What's 2a? Negative 2 times 2, so negative 4. So 3/4 is the x part of the vertex. How can I use that now to find my maximum distance? Substitute it in for x. I'm going to make everything here just a little bit smaller so that I have room to do that. All right, so my distance is equal to negative 2 times 3/4 squared plus 3 times 3/4 plus 5. 3/4 squared? 9/16 plus 3 times 3/4 plus 5. Can I reduce when I do negative 2 times 9/16? Yeah. I can divide both of those by 2. So I'm going to end up with negative 9/8 there. My distance is equal to negative 9/8 plus 9/4 plus 5. I'm going to need a common denominator. What should that be? 8. So negative 9/8 plus 18 over 8 plus what? 40 over 8. So what is my maximum distance? 49/8. You could have done that by completing the square. It would still be the y part of the vertex that we'd be looking for. I did want to show you another way that you can find the x and the y parts of the vertex. One last problem in section 3.6, and then we're going to start section 3.7 today. So we've got one more problem to do. Grab a picture if you need it. All right. Here's our last one that's in 3.6. I want to find an equation written in this form for the parabola shown below. What form is that?
Slope intercept?
Close, that'd be for a line.
Vertex intercept?
Isn't it something form?
Starts with an F.
Factored form.
Factored form, there we go.
Oh, with the solution?
Yes. This is factored form, and these two right here, x1 and x2, those are my roots, my zeros, my x-intercepts. Where are the x-intercepts on this graph? 4 and negative 2. So if I take that form right there and I substitute in my two roots, what is this going to look like?
X plus 2 and X minus 4.
X plus 2 and x minus 4. Because remember, we take our parentheses, our factors, set them equal to 0 to find those roots. I still need what? I still need A. Do I have anything that I can use to help me find A?
The 0.20.
The 0.24. So we're going to do that. I'm going to substitute 4 in the place of y, and I'm going to substitute 2 in the place of x. So instead of y equals, I'm going to have 4 equals. I don't know what a is, and I'm going to put 2 in the place of my x. So 2 plus 2 and 2 minus 4. What is 2 plus 2? 4. 2 minus 4. Negative 2. And then I multiply those guys together, so I get 4 equals negative 8a. What is our a value? Negative 1/2. So what is my equation then?
Y equals -1/2 x plus 2x minus 4.
Yes, y equals negative 1/2 x plus 2 x minus 4. That finishes off 3-6. This homework is due tonight. If you guys have any questions for me about this homework, please, please, please send me messages. Also, please don't wait until 10 o'clock at night to send me those messages, because that doesn't give me as much time to help you. Plus, I might already be asleep. But if you guys have any questions or any difficulties with the 3-6 homework, send me messages. I'm happy to help you guys tonight. If you need to grab a picture, go ahead and do that. And then we're going to start 3-7. All right, 3.7, we're going to do operations on functions. This is going to bring together a lot of the stuff that we were doing in 3.4 and in 3.5. Operations on functions. We have 4 operations that we can perform with functions that we're going to talk about today. We can add 2 functions together. That would be the sum. This is the same as taking our function f of x and adding it to our function g of x. We can find the difference of 2 functions, and this we actually just did. That problem with the parabola and the line, with that green shaded region, we found the difference of those 2 functions. We took one function and we subtracted the other function. What's happening between the f and the g and the third one down? Multiplying. This is the product. So we're going to take our function f of x, and we will multiply it to our function g of x. And last but not least, we can divide these. This is the quotient. So I'm going to take whatever my function f of x is, and I will divide it by my function g of x. These 3 up here will all have the same domain. For the one on the bottom, this guy can give us trouble. Because what's true about the bottom of a fraction? What can it never be?
0.
0. G of x cannot be equal to 0, and so oftentimes that means there will be a different domain for my quotient. When we're determining the domain for any of these, the domain must be within the domain of each function. So the domain for the whole thing has to be within the domain of each function, which means if -3 can't be used in my function f of x, then it can't be used in my sum of f of x plus g of x. We'll look at a couple where we have to figure this out. I want to practice these operations. We're going to do all 4 operations with 2 functions that I'm going to put up on the screen. And we're going to practice finding the domain for each of these. I'm going to use 2 different colors so that when you guys are looking up here, it's really easy to tell which function is which. And we're going to start off by doing the sum of f and g. So for the sum, I'm going to take my function f of x, and I'm going to add that to my function g of x. My function f of x is what? X squared plus 2. What is my function g of x? 2x squared plus 1. Are there any like terms that I can combine to simplify this? Yep. X squared and 2x squared. That'll give me 3x squared. And 2 plus 1? 3. When I go to do the difference of f and g, I have to be a little bit more careful. When I'm adding those 2 together, I don't have to worry about extra sets of parentheses. But when I'm subtracting 2 things, I do. I've got my function f of x, x squared plus 2, and then I'm going to subtract my function g of x, 2x squared plus 1. Please make sure to put the second one inside parentheses. I need to distribute that subtraction. So I'm going to have minus 2x squared minus 1. What things can I combine together? The x squared. So what am I going to be left with? Negative x squared.
And then -1 and 2.
Negative 1 and positive 2, so plus 1. Oh, thank you, you're right, I did. Negative 2x squared plus 1. For the product, we're going to multiply f and g together. Since f and g are both binomials, what do I need to do? What's this going to look like? I have x squared plus 2, and that's going to get multiplied to what? 2x squared plus 1. So I'm going to need to double distribute that. X squared times 2x squared gives me, 2x to the 4th. X squared times 1, I just get x squared. But then I still need to distribute the 2 to both pieces. So I get plus 4x squared plus 2. Any like terms to combine? There's x squared. So what's it going to be when I put it all together?
2x to the 4th plus 5x squared plus 2.
Yep. I said all three of these have the same domain. So let's do that real quick and then we'll go do our quotient. What is the domain of f of x? What are you allowed to use for x? All real numbers. What about for g of x? What's the domain there? All real numbers. So what do you think my domain would be for the sum, the difference, and the product? All real numbers. If I'm allowed to use it for both functions, then it works for the sum, the product, and the quotient. Or sorry, the sum, the product, and the difference, not the quotient. My bad. Spoke out of turn there. Doing the quotient of f and g. I'm going to have my function f of x in the numerator, my function g of x in the denominator. So I have x squared plus 2 up on top. I have 2x squared plus 1 down on the bottom. Can I reduce that at all? Can that simplify any further? Nope. That's my quotient. Talking about the domain for this, what's the only thing that could make it not all real numbers?
0, 0.
Hmm?
Wait, what? Oh, if the denominator was 0.
Denominator can't be equal to 0. So what value for x would do that? Yeah, if x squared was negative 1/2, is that possible though? Can I square something and end up with a negative?
No.
Not unless it's imaginary. So in this case, this is not possible. So do I have to worry about the denominator being 0? Not in this circumstance. So what is my domain here? All real numbers. We'll practice tomorrow with some problems where our domain does change as we do this. Homework for 3-6 quadratics is due tonight. The 3-7 homework is due on Thursday. And your test is a week from today. I want to get the reviews into your hands right now so that you guys have those and I don't forget to hand them out.